Ever wondered how OSPF keeps large network organized? Let's uncover its area structure and router rules. In this video, we'll give you a brief introduction to OSPF areas. So without wasting any time, let's get started. So guys, let's come to our slides and I'll explain OSPF there for you guys. So let's come to our slide. So today's topic is what? OSPF area structure. Let me explain it in a simple example for you guys. So think of OSPF autonomous system as what? As a large building. And in this building, we have a big event, which think of the big event as the network of OSPF. So when we want to manage that big event in the large building, we do what? We segment our event into parts. Like we have the main hall in the building, we have lounge, we have conference room, we have dining rooms, which each part do its own business, but still they are connected to each other through what? Through the main hall. OSPF is the same. The OSPF, when it wants to manage its network without getting it messy, so it do what? It just divide its network into parts, which we call areas, which the main area or the central area is called area 0 or backbone area. And other areas are the sub areas that should be connected to what? Area 0. Like, let's come to our slide. So OSPF is based on what? Based on areas. The central area is what? Called the area 0. And other areas should be what? Connected to area 0, which in each area we recommend from 40 to 50 routers in one OSPF area. Because of what? Because we don't want it to get messy. We don't want our routing table to be full of networks. 40 to 50 routers is like we can keep it manageable, but more than that, it's a little bit hard for us. So those areas that are not directly connected to area 0, what should we do with that one? So for those areas, we do what? Virtual link. What is virtual link? Virtual link is like a bridge, and it makes the area to think that is directly connected to area 0, but it is not connected directly to area 0. It is just work like a bridge that we connect one area to another area, and that area is used as a bridge, and it will connect us to the main area or the central area, which is area 0, which I will explain in the configuration in the next video for you guys. So OSPF use a hierarchical design. What does it mean by hierarchical design? We think of hierarchical design in OSPF as what? Like any small topology change is just limited to that single area. All our network that we have, like all the autonomous system of OSPF that we have configured, doesn't need to run the SPF algorithm. It is just limited to that area. And second, the OSPF, like in here we have, let me just open the topology for you guys. So as you can see in here, that OSPF divide or segment our network into two layers. What the first layer is area 0, and the other layer is other areas. Like we have, and here we have area 34, area 25, and let's just call this one area 5. Like this is, as you can see, it is a hierarchical design. It is a two-layer hierarchical design, or we can say collapsed layer, but still it is a hierarchical design. As you can see in here, all the areas are connected to what? Area 0, which connect other areas to each other through the central area. And this is what we call OSPF hierarchy. So let's come to our slides. So let's come to router types and summarization. So in OSPF, we have two router types. One is ABR and another one is ASBR. ABR is area border router, which connect what? As we know from its name, it connects two areas. This one is not two areas. It connects two areas. Like in here we have it connects like we don't need a pin, or we do need a pin. I think so. Like in here we have that this router, as you can see in here, it connects area 0 to what? To area 34. This is called what? A border router that connects one area to another area. Like it also connects area 25 with our area 0. So what are ASBR routers? ASBR or autonomous border router connect our network with what? With external network. Like in here we have it connect us to another network. Like we can also, it's internet, we can also call it OMP or BGP or EIGP. Overall, it just connects us to another network. So as I have told you, ABR connect different OSPF areas, and autonomous system boundary router connects OSPF with routing protocols or with other networks. So in OSPF, when we want to summarize our route, we do it manually, and it is only done on ABR and ASBR router that we have in our network, which I will summarize routes for you in the configuration. But right now, just drill it in your mind that summarization can only be done in ABR and ASBR router. That I will, summarization. I just don't need to explain it for you. If you come here and know OSPF, you better know what is summarization. So let's come to our other slide. Wildcard mask and router ID. So OSPF use wildcard mask to define network segment and OSPF configuration. When we want to configure OSPF, when we want to define a network to another router in OSPF, what do? We use wildcard mask. Wildcard mask, if you don't know about wildcard mask is the reverse of subnet mask. In subnet mask, let me explain it in here for you guys. Windows T+R, notepad. So let me zoom it in. So wildcard mask is like, so we have subnet mask, like in here we have 192.168.1.0. This is our what? Our prefix. And this is our what? It's subnet mask. You can see it in here. So subnet mask is used to specify in our prefix that which octet is network and which octet is But wildcard mask is the reverse of subnet mask. It is not same as the subnet mask. It is the opposite of wildcard mask. It is the opposite of subnet mask. So a wildcard mask work like this, that we have matter and don't matter. Whichever part of our prefix or whichever octet in our prefix we specify as 0, it means as what? It means it matters. And it matters, and the OSPF should match this one when we want to make neighborship with our neighbor. And the 255, just learn the basic. The 255 means what? That it doesn't matter. Like in here I have 0 for 192, 0 for 168, and 0 for 1. Like I want to make the router to know that these 3 parts of our prefix matter. These 3. You should match these 3. And the last one, when you want to make neighborship with someone, I have specified it as what? As 255. That it doesn't matter that you need to match this one. So when you want to make neighborship, so our router will not make connection with 192.168.2.0, 2.1. Because of what? Because of I have told it to match this one. I have specified it as what? As 0. So it will not make neighborship with a network like this. But if I write it like 192.168.1.10.20.30, whatever I write, up to 255. Like in here we have 255. It just match it. Like we have 254. I don't think so. It's still we can write 255 in our IP address, but 254. Whatever number I write, it doesn't matter. So this is the job of wildcard mask. So let's come to our slides. So OSPF Router ID. So Router ID is a unique identifier for OSPF router. We can specify it manually, and we can also specify it using OSPF. If you don't specify it manually, it will just give it the highest prefix that we have in our network will be selected as the router ID in here. And process ID identify OSPF process on a router. So Process ID, it doesn't matter. It doesn't need to be same between two routers, and process ID is just as it identifies OSPF process on the router. Like I just want to I have two connections with two routers. Two connections with two routers. One of them I specified as OSPF router OSPF 1. That one is the process ID, and another one I will specify it as 2. I just don't get the idea of so much importance of the process ID, but still, it doesn't matter to be same between two routers. That if we configure it, like if I configure it in here between the, like we have the ABR one in backbone router. If I want to configure routing between these two routers, the OSPF process ID doesn't matter to be same. Like if I configure router OSPF 1 in here, I can configure in here router OSPF 2. It is limited to the router. It is not limited to both the one that we make connection with. So I have talked a little bit over, I think so, but still, let's keep going. So let's come to another slide. So we have designated router in backup designated router, or BDR. This is one of the topics that I have told you the other day that I will explain it with what I have told you. And in this slide, I told you that the multicast address, I will explain it in another video. This is the video. So we have DR and BDR are two rules in OSPF, in an OSPF area or in an OSPF network. These two router rules are inside the area. We use DR and BDR in a broadcast network. We don't use it in a point-to-point network. It just works in a broadcast network. So like in here, we have this, open this in the whiteboard. Here's our whiteboard. So like we have this network, right? Let's zoom on it. This network. So in this router, which is R1, a network got down or disconnected, whatever the reason, the 192.168.2.5, think of it, /.5/24. This network got down. This network in the R1, it will send a packet to R2 that this network on my router got down. So, and R1 will broadcast that this network got down in my network, in my routing table. So it tells them that delete it from your routing table. So R2 and R3 will think that, let's call R2 first. R2 will think that R1 called me that this network is down. Now R2 thinks that R3 don't know that this network got down. So it will also broadcast that this network got down. So after this router call this one, so R3 will still also think that R2 also don't know that this network got down on R1. This will also broadcast in our network that 192.168.2.5/24 got what? Got down. So for this problem, the DR and BDR come into picture in broadcast network. So what is the rule of DR and BDR? So DR is designated router and BDR is the backup designated router. So like in here, I have a small topology, but in big networks. So in big networks, it's also the same thing, but a little bit not complicated, but still the same. So in OSPF, in broadcast network, one router is selected as what? As designated router, which will have the highest router ID. And we have some other processes, but still, let's call it the one with the highest router ID will be selected as the DR. And those with the a little bit lower than that one will select it as the BDR, backup designated router. DR is like the admin, and BDR is like the back of the admin. Whenever the DR is down, the BDR will take the role. So let's think of this one as DR. So let me take that. This is what? This have become the DR. DR. This router become what? As the DR. Let's select R2 as the BDR. So let's think of this network in the R3. That this network got down. So what is the rule of DR right now in here? So the DR will do what? No, the R3 will send a packet to multicast address of 224 2.0.0.6, which is the address of what? The address of the DR, that this network got down in my routing table. So what will the DR do? The DR will then broadcast a packet with the multicast address of what? 224.0.0.5, and notify all the routers in our network. Like in here we have 3 routers. There will be 40 to 50 routers, that this 192.168.0.2.5 network got down, and all the routers will get what? Notified in area 0. So the other routers don't need to just call the others. They will just trust the DR that this network got down, and they will just delete it from their routing table. And what is the role of BDR? So whenever the DR get down or the router shut down for whatever reason we have, so the BDR will take the role of the DR. This is the rule of BDR. So I think I just explained it very well for you guys. So if you didn't get the idea, you can comment down below. Whatever you didn't get, you can just comment it down below, and I will just explain it in another video for you guys. So as I told you before, the election process is based on router priority. We have router ID. It will create a single point for objects in our network. So OSPF has 2 neighborship class, two-way and fully adjacent. So what is two-way and what is fully adjacent? So OSPF routers will make a fully adjacent or full connection with what? The DR routers, and a two-way connection with other routers. What is the difference between two-way neighbors and fully adjacent? So the difference between two-way neighbors and fully adjacent is that two-way neighbors is that it just don't take updates from what? From the other routers that it have two-way connection with. Like in here, let's add a router. Let's just draw it. So we have this router that is connected to our network, right? Our network. So let's call it R4, right? So the R3 that we have in here will a fully adjacent connection with the DR and the BDR. What does it mean by fully adjacent? It means that R3 will send fully update with what? All the updates, all the topology that we have in our router, only to the DR and BDR. And it will have just a two-way connection with the other routers that are not DR and BDR. The two-way connection is just like it will just send packets, basic packets, data packets to each other, and not the multicast packet. Only the multicast packet are only sent to what? The DR and the BDR. So that's how it works. A fully adjacent and the two-way neighbors. هذا فيديو اسمه class.